Good day. We will now discuss confidence intervals. So let's start with estimate or estimation. Estimation is the process of estimating the value of a parameter, meaning this is from or based from the population. So from information obtained in a sample. So we will estimate a parameter based now on our sample data. So a point estimate is a specific numerical value estimate of a parameter. So example, if you want to estimate the population mean, the best point estimate for this one is the sample mean. So when we talk about point estimate, it is a specific numerical value. So only one value. Okay, now how about an interval estimate? An interval estimate of a parameter is an interval or range of values used to estimate the parameter. So meaning the parameter is specified between two values. So in this case, we have the population mean, and we have the lower limit and the upper limit. So say for example, we have 2 less than the mean less than 5. Meaning the mean is between 2 and 5. Now, a degree of confidence or confidence level can be assigned before an interval estimate is made. It is the probability that the interval estimate will contain the parameter. So for confidence intervals, for estimating the population mean when the variance is known or the sample size is greater than or equal to 30. So by the way, when we say this one is about the population variance, so this is known and n is greater than or equal to 30. So since it's using or, so either of these, if one of these is satisfied, then you will use z. Okay, because of this word or. So one of these two must be satisfied in order for us to use z. So we have this as our formula. So it's plus and minus because the minus there is for our lower limit, this one. This is our lower limit, and this plus sign is for the upper limit. And of course, the population mean being estimated is at the center. Okay, so most common used confidence level are the 90%, the 95%, and the 99%. So we'll be using these values in order for us to solve the preceding problems. So if it's given with 90% confidence level, then we'll use 1.645 as our value for z alpha over 2. 95% confidence level, we'll use 1.96. And for 99% confidence level, we'll use 2.58. Okay, so we will use 2.58. Now, if you ask the question, why is it alpha over 2? It's because when we draw this normal curve, we're taking both sides of the normal curve. So we have the lower limit and the upper limit. So that is why our alpha is now divided into 2. This will be our alpha over 2. And this one is also our alpha over 2. Okay, next, for estimating population mean when variance is unknown, so the population variance is unknown, and take note, and the sample size is less than 30, then we will use the t distribution. Take note of this. This is t. Take note also, and, so meaning both of them must be satisfied. For the z, since it is or, either of these two is satisfied in order for us to use z. But if both of these two are satisfied, meaning this is unknown, and n is less than 30, then we will use t. Otherwise, we will use the other one, z. Okay, so this is our formula. Or you can have this one. This is again our lower limit. And this is our upper limit. Okay, so the S here is this sample standard deviation. So this is wrong. So this should be S, the sample standard deviation. And X bar, of course, is the mean. And N is our sample size. So again, as a review, when to use Z or T. First, if sigma is known and N is greater than or equal to 30, then use Z. Next, if sigma or the population standard deviation is unknown and N is greater than or equal to 30, then use Z. Or in short, if this is known or N is greater than or equal to 30, then use Z. Okay, because on this first one, both of them are satisfied, so use Z. And of course, for the second one, for this one, only one is satisfied. Now, we can also use Z because of the word or, right here, no? Or either of these two or both will be satisfied. So use Z. Otherwise, you use T. For T, sigma is unknown. This should be unknown. The population standard deviation is unknown. And N must be less than 30. Less than 30. So both of these two must be satisfied. Then we will use T. So to understand further, let's go to our examples. Okay, so before that, we have this note. This one, which is this and this, they are called the margin of error, or our notation for this is E. So this refers to the maximum allowable difference between the sample and the true value. So take note of the word maximum allowable difference between our sample value and our true value of the population. So examples. So a survey of 30 households found that the mean age of an LED TV is 4 years. Assuming the standard deviation of the population is 0.75 years, find the 99% confidence interval of the population mean. So of course, we'll start with a given. We're given first with N. N is equal to 30 households. And the mean age of an LED TV is 4 years. So this is mean, sample mean. So this 4 years corresponds to these 30 households. So of course, this is our sample. So this will be our sample mean. So 4 years. Next, assuming that the standard deviation of the population, so meaning this is the population standard deviation, is 0.75 years. Find the 99% confidence interval of the population mean. Now, what are the given? We're given with N greater than or equal to 30. Right? N is equal to 30 means it still falls on this one. Okay? And of course, the population standard deviation is known. Right? So it is known and N is greater than or equal to 30. So this means that we will use the z distribution. Okay, because of this 2, n is equal to 30, which satisfies this one, and this is known, the population standard deviation is known, then we will use z. Okay, so first, I prefer to solve first the margin of error. So our e, since this is z, so we will use this. Because later we'll just do this. So for example, for this one, this will just become x bar minus e. Then we have the mu, and then we have x plus, or x bar plus e. The same is true here. So we have the x bar minus the margin of error. We have the population mean, and then x bar plus the margin of error. Okay, so let's first solve the error. So this is our e. So our formula here is z sub alpha over 2 times the population standard deviation over the square root of n. Here, this one. Okay, so let's compute. So z sub alpha over 2, since this is 99%, so here at the bottom we have 99%, and this is z alpha over 2. So of course we will use 2.58. So therefore we have 2.58 times our standard deviation, or population standard deviation, is 0.75 divided by the square root of our n, which is 30. Now you can use your calculator now. So 2.58 times 0.75 divided by square root of 30. So the answer is 0.353. So we'll just use 2 decimal places. This is 0.35 because the next number is 3. So rounded off to 0.35. Therefore, our estimate here will be like this. So x bar, or the sample mean, minus the margin of error, then our population mean, then we have again our sample mean plus our margin of error. So what is our sample mean? It is 4, this one. So we have 4 minus 0.35, and the other one is 4 plus 0.35. So using your calculator, you subtract. So we have 3.65, and on the right side, of course, that is 4.35. Okay, so this is now the 99% confidence interval of the population mean. Thus, one can be 99% confident that the mean age of LED TV is between 3.65 and 4.35 based on 30 LED TV. Next, a recent study of 19 students of San Sebastian College, Recoletos, Manila, showed that the mean of the distance they traveled to go to school was 10.2 kilometers. The standard deviation of the sample was 2.3 kilometers. Find the 99% confidence interval of the true mean. Okay, so let's write first the given. So we're given with a sample size of 19. So n is 19. The mean of the distance they travel was 10.2 10.2. So this 10.2 kilometers here refers or corresponds to these 19 students. So this is our sample mean. So 10.2 kilometers. Next, the standard deviation of the sample. So meaning this is S. So this is 2.3 kilometers. So again, find the 99% confidence interval of the true mean. Okay, so N is 19, so this is N is less than 30. Okay, so N is less than 30. But of course, it means that we will not use Z. Instead, we will use T. But of course, we must be sure. Okay, let's look at the standard deviation. What is given? Is it the population or the sample? So based on this, the standard deviation of the sample. So the given is the sample, not the population standard deviation. Okay, because if the given is the population standard deviation, then of course we will use Z. Okay, we will use Z because the requirement for Z is either N is greater than 30 or the population standard deviation is given. Okay, but of course in this particular problem it is not given. The sample standard deviation is given. So meaning both of these are satisfied. Take note for the t-test, this is our connector and so meaning both of these two must be satisfied. Since both of these two are satisfied, then we are sure that we will use the t distribution. Okay, so this is the t distribution. So again, let's start with our margin of error, E. So our margin of error is this, T sub alpha over 2, comma, the degrees of freedom, and then times the sample standard deviation divided by the sample size N. Okay, so we're given with 99%. So to find alpha, remember in our previous topic on the introduction of t-distribution, to find alpha, we just subtract. So 99% is 0.99. So we'll subtract 0.99 from 1. So meaning this alpha is 0.01. Okay, so alpha is 0.01. But take note, we need alpha over 2. So alpha over 2, so we will divide this by 2. 0.01 divided by 2 is 0.005. Okay, so we have now 0.005. So our first here sub 0.005. Now how about the degrees of freedom? Our degrees of freedom is n minus 1. So this is 19 minus 1, so we have 18. Okay, so 18. Next substitution, our S is 2.3 and our sample size N is 19, so square root of 19. Okay, by the way, this is 2.3, so this is not included. So what is this? T 0.005, so this one 0.005, and then 18 our degrees of freedom. So therefore our T value here is 2.878. So 2.878 times 2.3 divided by square root of 19. So you use your calculator. This is now 2.878 times 2.3 divided by square root of 19. So the answer is 1.52. Okay, so therefore, again, we will use this x bar minus e. We have the mean or population mean, then x bar plus e. So this implies that what is our x bar? X bar is 10.2. So 10.2 minus 1.52. Then we have the mean. And on the right side, we have 10.2 plus 1.52. So let's subtract. So the answer is 8.68. Our lower limit is 8.68. And our upper limit is 11.72. Okay, so thus one can be 99% confident that the population mean of the distance traveled is between 8.68 and 11.72 kilometers based on a sample of 19 students. Next, an independent researcher went wishes to estimate the average amount of money a young professional spends in clothing each month. A sample of 40 young professionals who spend in clothing found the mean to be 500 and the standard deviation is 80. Find the 95% confidence interval of the population mean. Okay, so let's write first the given. Our n is 40. Okay, our n is 40. And our mean, this mean here corresponds to the sample of 40. So this is x bar 500. And the standard deviation is 80. So take note, this standard deviation is not the population standard deviation. This refers to the 40 young professionals, so the sample. So meaning this is S. So find the 95% confidence interval of the population mean. Now let's examine again if it's T or Z. Of course, from this first given, n is greater than or equal to 30. So it means that we will use the Z distribution. Now, if you ask, sir, why is it that we will be using Z? There is no population standard deviation. Now, in cases like this, the sample standard deviation will be substituted as our standard deviation in our computation, as long as our n is greater than or equal to 30. Okay. So, therefore, our E here looks like this. So, Z alpha over 2. Then, instead of the population standard deviation, we will use the sample standard deviation. And then, divided by square root of n. Okay. Now, again, take note, if we are gonna use Z, it's either n is greater than or equal to 30, or, take note of this, or this is known. or this is given. So since this is satisfied, then of course we will use the z-score. And then of course this population standard deviation from our formula will be substituted by the sample standard deviation. Okay, so that is the rule. Okay, so the z alpha over 2, 95%. So we have here 95%. So we have 1.96. So 1.96. And then the S, or the sample standard deviation, is given by 80. And then divided by square root of 40. Okay, so you try using your calculator to check. Square root of 40. So 24.79. So this is equal to 24.79. So therefore, this is our interval. So our sample mean is 500. So minus 24.79. And on the right side, our upper limit is 500 plus 24.79. So 500 minus 24.79 is 475.21. So that is our lower limit, and our upper limit is 524.79. Thus, one can say with 95% confidence that the true mean of the population is between 475.21 pesos and 524.79 pesos. This is based on a sample of 40 young professionals. Next, find the 90% confidence interval of the population for the incomes of executive secretaries in Makati City. A random sample of 30 executive secretaries is shown. The data are in thousands of pesos. Now, let's look at the given. So, our given first is n is equal to 30. So, of course, this is now greater than or equal to 30. So, satisfied ang first condition for the z. So, because of the word or, so only one can be satisfied. So, we will use the z distribution. Okay, because of our n. Next, of course, if you want to check, our population, our sample mean rather is equal to 18.3. All you need to do is you just add these numbers and then divide by 30. Next, of course, because these are samples, so based on these samples, we can compute for the sample standard deviation, which is equal to 4.07. So again, the same with example number 3. Although the population standard deviation is not given, we can have our sample standard deviation as a substitute. Okay, so therefore our margin of error is the z sub alpha over 2 times s over square root of n. So it says 90%. So 90% is here. Or z alpha over 2 is 1.645. So 1.645. And our s is 4.07. And our n is 30. So you can use your calculator. 0.7 divided by square root of 30. So the answer is 1.22. So therefore again, this is our interval. So just substitute. Our sample mean is 18.3. So minus 1.22. And of course, on the other side, on the upper limit, is 18.3 plus 1.22. So 18.3 minus 1.22 is 17.08. And our mean upper limit is, of course, 19.52. Okay, so this is now our estimate of a population mean. Thus, one can be 90% confident that the population mean income is between 17,080 and 19,520 based on a sample of 30 executives. Okay, next. 5. A random sample of 5 families in a particulars resulted in the following sizes. Find the 95% confidence interval of the mean. Okay, so our n is given by 5. And of course, you can compute for the sample mean by adding these numbers and then divide it by 1, 2, 3, 4, 5, 6, 7, 8. Divide this by 8. Okay, so this is 8. This should be 8. A random sample of 8 families. Okay, so 8. So our n here is 8. So this should be 8. Okay. So because there are 8 data, the 8 sizes of a family. So x bar is equal to 5.5. You can compute that one, you can check that one. And then the sample standard deviation is equivalent to 2.45. Now let's check. Our n is less than 30. So obviously we will not use the z, but we will check the standard deviation. Of course, the standard deviation is sample. So we will not use the z. Instead, we will use the t distribution. Okay, we will use the t distribution because our n, which is 8, is less than or equal to 30 or less than 30. And the sample standard deviation is given. The sample standard deviation is given. So both of these are satisfied. So meaning we will use the t distribution. T distribution. Okay. So let's first compute for our e. So our e looks like this. T sub alpha over 2, comma, the degrees of freedom, times the s, or sample standard deviation, divided by the square root of n. So what is our alpha? Okay, our alpha here is 1 minus 0.95. Okay, because of this, the 95% confidence interval. So therefore, this is equal to 0.05. And then, so we divide this by 2. 0.05 divided by 2. This is equal to 0. So this is 2. 0.25. And our degrees of freedom. Our degrees of freedom is 8 minus 1, which is 7. So therefore, we have now t 0.025 comma degrees of freedom of 7 times our s is 2.45 divided by our n is 8, so square root of 8. So this is further equal to 0.025 here, and the degrees of freedom is 7, so our t value here is 2.365, and then you just copy the 2.45 and the square root of 8. Okay, then you compute using your calculator. 2.45 divided by square root of 8. So we have 2.05. So this is equal to 2.05. So thus we have our interval like this. So our sample standard deviation is 5.5 minus our E, or margin of error, is 2.05. Then our upper limit is 5.5 plus 2.05. Thus we have 3.45 as our lower limit, and our upper limit is 7.55. So this is our interval. Thus, one can be confident, or 95% confident, that the population mean of the family size is between 3.45 and 7.55 based on a sample of 8 families. The average hemoglobin reading for a sample of 20 teachers was 16 grams per 100 milliliters with a sample standard deviation of 2 grams. Find the 90% confidence interval of the true mean. So again, let's start with the given. We're given with n equals 20. And our average for this 20, so sample mean is 16 grams per 100 milliliters. And then the sample standard deviation is 2 grams. So we will use Ty because our n is less than 30 and our sample standard deviation is given. So both are satisfied. So that is why we will use T. So our E therefore is equal to T sub alpha over 2 comma degrees of freedom, and then we have S over the square root of n. Now let's start with alpha. So this is 90% confidence, so we have 0.9, so 1 minus 0.9. Therefore our alpha is 0.10 or 0.1. So divide it by 2, so 0.10 divided by 2 is 0.05. Next, the degrees of freedom, that is n minus 1. So our n here is 20 minus 1, it's 19. Okay, so therefore this is now T sub 0.05 comma 19 times s over square root of n. Okay, let's move it here. So times s over square root of n. So what is the value of t? 0.0519. So here 0.05 and 19 is here. Okay, so this is now 1.729. 1.729. Okay, 1.729. Then multiply this by s, or standard deviation, which is 2, and our square root of n, or square root of 20. So what is this equal to? 1.729 times 2 divided by square root of 20. So the answer here is 0.77. Okay, so therefore our estimate looks like this. So our sample mean is 16 minus 0.77, our margin of error. And then we have 16 plus our margin of error. So 16 minus 0.77 is equivalent to 15.23. And of course, we have 16 as our upper limit, 16.77. Therefore, one can be confident that the population mean is between 15.23 and 16.77.